As a former California lawmaker, I certainly have seen the interface between politics and economics when it comes to global warming. I can remember as if it was yesterday rising to oppose AB 32, the California Global Greenhouse Gas Solutions Act of 2006, talking about things like solar variability and orbital mechanics and how we've had numerous ice ages in the past when we didn't have industrialization. And when I put down my mic, the very next person to raise their mic, a very liberal Democrat from Los Angeles, first words out of her mouth were, "Poppycock! Flat Earth!" And she went on to say that everything that I was talking about was utter nonsense and was non-scientific, and clearly I was a benighted fool. Well, what I like to ask the question is why is it that the same people that are proposing massive intervention in markets to make more humans miserable were proposing the exact same solutions some 40 years ago when we were worried about global cooling? And now we're worried about global warming, and it's the same exact solution. Could it be that what they're more concerned about is centralized control of the economy than perhaps of the environment or the climate on planet Earth? Perhaps. Maybe we should think about that. So for the next hour together, we're going to be studying and discussing the issue of economics and politics as it relates to the global climate and these so-called solutions to save us from ourselves. We have three remarkable panelists with us today, and what we're going to do is hear from each one in sequence and then hopefully have enough time for some Q&A. So the very first individual that we're going to be hearing from is Mark Mills. Mark is a senior fellow with the Manhattan Institute, certainly a group that I've come to admire very much over the years. He's also a faculty fellow at the McCormick School of Engineering at Northwestern University and CEO of the Digital Power Group. He writes a tech column for Forbes and co-authored the book, The Bottomless Well. His two most recent papers are The Cloud Begins with Coal and Shale 2.0, Technology and the Coming Big Data Revolution in America's Shale Oil Fields. During the Reagan administration, Mark served in the White House Science Office, working as an experimental physicist and development engineer. He was a little before my time in the Reagan Pentagon. Mark is also a member of the Advisory Council of the McCormick School of Engineering and Applied Sciences at Northwestern University and serves on the board of directors of the Marshall Institute. Ladies and gentlemen, Mark Mills.
Well, thank you for the kind introduction. Thanks for having me join you again. This is a terrific gathering, and thank you, Kathleen, for the kind invitation. I'm going to talk about economics and not climate science, because the subject of our panel is about economics and politics. And I'm only going to speak very briefly. I'm hoping we can have more time for Q&A, particularly in the issues relating to the political dynamics of dealing with this issue. But what I want to point you to, and I'm going to elaborate on, is what I would say is a political gift given to us by Bill Gates. So those of you who have not read it, I assume everybody here probably has by now, that the latest issue of Atlantic Monthly has an extensive interview with Bill Gates about climate change and about energy. The interview is essentially all about energy. The only time he spends in the interview about climate is to genuflect to the proposition that it is changing and that the changes are caused largely by man and that there are important changes that have to be mitigated. Right? So he's genuflecting to the orthodoxy in the public sphere that climate change is a problem. And that's it. If you haven't read the interview, he doesn't say any more about the science. He doesn't talk about variability or extremes. He just says we need to deal with it. And then he goes on to point out, and this is what's relevant to economics, is he points out that the problem, and in his words, it's the energy problem has to do with, and I'm paraphrasing, scale and in economics. And then he goes on to say that in order to understand this, you have to, in his words, bring math to the problem. So I'm going to do a little bit of the math that he's talking about. And it's interesting what his conclusion is, by the way. He says right up front what his conclusion is that the problem is that we need, in his words, a miracle in science and technology in order to make any changes in how the world gets energy that are meaningful. A miracle. And then he proceeds to explain what he means by that. So let me pick 4 of the things that he talks about and provide you with some of the math that's behind his statements. And by the way, I'm not saying things that I don't believe he doesn't know himself. I'm sure he does. He's given other talks privately where he says things similar to what I'm saying. And some of them I'd like to believe he's saying because of things that I've written. As some of you may know, he unintentionally endorsed our book, Bottomless Well, back when it came out, which was a gift to us from the viewpoint of sales. It does help when somebody like Bill Gates says they like your book. And of course, the publisher put it on the cover of the paperback. And he has, I believe, read other things I've written since, and in fact is using language privately that's identical. I won't call it plagiarism because he's not writing this, but identical to what I've written frequently about solar power and about batteries and so forth. So let me give you 4 of the facts that he laid out. And the first thing he said was that because hydrocarbons provide, as you all know, 90% of the world's energy, he said the first problem is that energy is so big. Everything uses energy. Energy is involved in everything. And it's an obvious thing to say. It's amazing how infrequently people accept that reality. And in my view, in the political world, that's the equivalent of saying that doing something about energy is more difficult than implementing industrial policy. You know, the West gave up the idea of an integrated industrial policy. I mean, the Soviet Empire tried it a long time ago. The energy policy is actually bigger than industrial policy since it involves everything, right? Everything from food to Facebook, everything involves energy. In fact, just kind of facts that I tell students when I lecture them is that it takes roughly the same amount of energy to produce 15 hamburgers as it does to move 150 gigabytes through Facebook to a smartphone. And there's a lot of hamburgers consumed in the world, and there's a lot of gigabytes consumed in the world, and both are growing. And maybe, as you know, my paper that you mentioned, The Cloud Begins with Coal, was one of the studies that I did that looked at the global scale of the energy appetite of the cloud, of the global internet. And it's not that I was doing any groundbreaking work in a sense. I was pulling together research and analysis done by many others. But the bottom line is already well known and not in dispute. The global internet uses more energy today than global aviation. And the energy appetite of the internet is growing faster than global aviation, and in fact is a more difficult problem to solve, frankly, than the aviation energy problem. So let me give you one bottom line number sort of in the math trope that Gates laid out, which is what is at the center of what he says is the problem, is that if you look at the world today and you know that the world is growing and there's a lot of people who have wealth that doesn't exist, that is, they want more wealth, and if you assume that of the 4 billion people today that don't have much, those 4 billion achieve a level of energy use that's 15% of that in the West. Not 50, 15%. So if those 4 billion go to 15% of the level of our individual energy use, the amount of additional fuel the world has to supply will increase by the amount equal to a total consumption of the United States. And that's just to get the 15%. The second fact said he's laid out was that there were no overnight miracles. Having said that there's a need for miracles, these things don't happen quickly. So he laid out in his taxonomy how long things take. But you know the numbers. And in fact, some of the examples that I like are pretty instructive. If you think about this, from the invention of the internal combustion engine to a point in time when 5% of Americans had a car, took 25 years. It takes a while. That's a high velocity impact because it was so incredibly useful. If you look at from an energy supply perspective, the last time we had anything new, miracles in energy was, I'd put the dates at 1905 when Albert Einstein got the Nobel Prize for the photoelectric effect. In 1939 at Stagg Field when we established that nuclear fission could be controlled and stimulated by man. And in the ensuing 7 decades, the world has produced lots of uranium and photovoltaic power, and it's grown. But today, the combined contribution to world energy from those two sources, 7 decades later, is 4%. In fact, on the 25-year number, which is kind of an interesting number, because in politics, 25 years is forever, of course. 2 years. You know, the timelines for Congress and the forward-thinking congressmen and senators think in terms of maybe a decade. Hence the Kennedy charge, right? Within a decade, we'll go to the moon. A decade's a long time for a politician, but they can deal with a decade. 25 years is forever. We're coming up next year to the 25th anniversary of George Mitchell's demonstration, I'll call it in the invention of hydraulic fracturing of shale. 25 years. And over that 25 years, you know the explosion in productivity in America. But as important as that is, and I'll talk about that later this evening, but as important as that is, just for context, and as big as it is in America, and as astounding as it is in America, the addition of fuel to the world's energy from the shale revolution in America now comprises an addition of 3% of world energy use after 25 years. And a lot of money spent, about $900 billion of private sector capital spent in the United States to add those 3 percentage points to the world energy supply. The third point that Bill Gates likes to talk about, and he does it frequently, is about this nonsense. His word was almost as strong as mine. He said meaningless, this meaningless statement from green advocates that we're approaching PV parity on the grid with solar panels. His word is it was meaningless to say it, even if we, quote, achieve it. The reason he's saying that is obvious, right? The sun is an episodic source of energy, and if you want to make electricity at scale, since it's the only energy source and only thing that human beings use at scale for which we don't store, right? We only store in America and all the batteries that exist in cell phones and cars about 5 minutes worth of annual electric demand. And every other commodity from grain to copper to coal to oil and gas, we store from 3 to 6 months of annual energy demand to provide the kind of stability in markets that are required. So electricity is sort of weird and unique. So even if you get to, quote, grid parity, and even if solar panels were as cheap as street signs, then the electricity delivered to the grid at scale would still be 300% more expensive than the grid is today. That's why he said it's meaningless. You can't have more expensive energy in the future. It has to be cheaper. The fourth point I want to pick up on that he made, which is relevant because of the nature of the political appetites and what many politicians are supporting. They support solar panels. They support wind because it requires is storage. Storing is because the two darlings of the green movements for clean tech are, of course, the episodic sources of wind and the sun, as you know. And so the solution that they're offering is this revolution, quote unquote, in storage. And batteries have gotten a lot better. In fact, batteries have gotten, by any reasonable measure, somewhere near 300% better than they were only a decade ago. It's really quite an impressive engineering achievement in physical chemistry. Really quite remarkable. We're starting to approach the asymptote in the physical chemistry, by the way. I mean, you can't make batteries work better than the inherent chemistry. It's just not possible. You can't get perfection. It's like you can't have 110% thermodynamic efficiency. You can't get more out of lithium than exists in the bonds of the lithium molecules and atoms that are associated with it. But anyway, here's the single fact point you need to know about storage trope. Elon Musk is building a gigafactory in Nevada, which will, if it is finished, it may not be, produce more lithium batteries than all of the world's lithium battery factories combined. So if we wanted to use that factory and build a battery tank farm to store as much energy as is stored in the Cushing oil tank farm. Cushing, as you know, is one of many oil storage tanks in the United States to hold oil to stabilize, essentially, the supply chain. So it's one of 7 major oil tank farms. If you wanted to build enough batteries to duplicate the energy storage capacity of Cushing, you would need 40 gigafactories operating for 100 years of production to match Cushing. It's an interesting scale problem. I think Gates knows his arithmetic. I don't know if he did that calculation. I've published it many times, but he's probably aware of it. PR aside. So what Gates has called for, as you may know, is more research to get miracles in science. He wants to triple the basic R&D budget of the federal government. I'm all in on that. I like that a lot. But he doesn't want to do more cylinders. He didn't say this. This is my language. He wants more scientists. I'm good for that. I'd like to support him on that. But the interview he gave, is an extremely powerful and damaging interview with respect to the political play that's now being pushed by the Greens to get more subsidies. Thanks.
Well, thank you for that very insightful contribution. 40 gigafactories for 100 years to equal Cushing. The storage capacity in Cushing. That is mind-boggling. We're next going to hear from James Taylor. James Taylor is Vice President for External Relations and a Senior Fellow for Environment and Energy Policy at the Heartland Institute. For 15 years, James was the managing editor of Environment and Climate News and now writes a weekly column for Forbes that appears on the magazine's Forbes.com website. Taylor has presented energy and environment analysis on all of the major networks and PBS as well, including PBS Frontline. That must have been rather unnerving because they pre-record you, right? And they can dice you up and present you any way they please.
Yeah, but they still can't win.
All right, very good. That's nice to hear you say that. He's also been published in virtually every major newspaper in the country. He has been the featured speaker at conferences sponsored by such groups as ALEC, of course very familiar to many of the folks in this room, National Foundation of Women Legislators, State Policy Network, the Cato Institute, Heritage Foundation, and the European Institute for Climate and Energy. Taylor received his bachelor's degree from Dartmouth College, where he studied atmospheric science and majored in government, so he was already studying that secret government weather control machine at Dartmouth in his undergraduate time. He received his JD from Syracuse University. That would be in Orangeman, right?
That would.
All right. Ladies and gentlemen, James Taylor.
Well, thank you so much for the kind introduction and kind reception. One thought, as Dr. Mills was speaking, he made a very interesting point that the internet emits more carbon dioxide, utilizes more energy, whatever, than air travel. And one of the things that I am constantly challenged with is finding a way to relate the importance of free markets and sound science to today's younger generation. I mean, it's very hard. They're getting the propaganda from youth, but you just hit upon it.
It works.
Because of global warming, we're going to take away your internet. You just hit it.
No Instagram.
Instagram.
Gone.
Yeah, exactly. So there you go. You put it in those terms, and we can get people to pay attention, which is really what it's all about. If they pay attention, then we win, because science is on our side. We heard some very compelling science earlier today, and what I'd like to do is discuss some of the economics, some of the political implications as well. Oftentimes people will say, okay, sure, James, but even if you're right, why not? We have this low-cost or no-cost alternative to fossil fuels that has tangential environmental benefits, so why wouldn't we be in favor of that? Or another line of argument, they'll say, well, we should have an insurance policy. I mean, this is an insurance policy. It costs very little, and we're going to alleviate a lot of risk. So I think it's important to keep in mind, on either line of reasoning, we have to keep in mind what are the costs that are involved, what are the risks that we are attempting to avoid, and what are the side effects of their prescribed solutions. When you talk about insurance, for example, if I have a $200,000 house and I'm paying $50 a month to insure it against fire, to insure it against hurricanes, tornadoes, that's a good deal. But if I have a $200,000 house and my premium is $600,000 a year, well, that's a bad deal. My house isn't going to burn down 3 times a year. So insurance makes sense only when it makes sense. So one of the things we have to keep in mind is these are the things that unites us. Economic opportunity and economic strength, as well as environmental stewardship. That's what comes in when we're talking about insurance, when we're talking about alternative energy paths. So let's take a look, first of all, at economic opportunity and energy economics. By the way, just for folks that are watching on the streamline, as I look up at a 15-degree angle, I'm not trying to emulate President Obama. I know it makes me look like I'm appealing to a higher voice or being inspired, but we have a nice screen up above that I get to see my slides here. But who knows, maybe I can reach his level of inspiration. So the comparative cost of electricity, the long and short of it is this. Wind and solar power, which are the two preferred sources of the global warming activists, they are prohibitively expensive. They are a horrendous choice if we're talking about insurance. They're a horrendous choice if we're talking about the importance of economic prosperity. Now, let me give you a couple of sources. First of all, I'm going to cite last year a study by the Brookings Institute. For those of you who know the Brookings Institute, it is not a hard-right think tank. It is left of center. These are folks who generally are in favor of renewable power, so I'm not cherry-picking my sources. What did they find? They issued a report, you see the title there, Why the Best Path to a Low-Carbon Future is Not Wind or Solar. That's the Brookings Institute. The reasons why, the two key findings in their study. Replacing conventional power with wind power doubles electricity costs. Now, Dr. Cooper mentioned earlier that black people wouldn't pay a penny, 52% wouldn't pay a penny more to fight global warming. And polls have shown it's not just black people. It's black people can be very smart. So can others. It's multiracial. People do not want to pay that for an illusionary benefit. You're talking a doubling of electricity costs for wind power. Solar power is even worse. According to the Brookings Institute, replacing conventional power with solar power triples electricity costs. Folks, that is an exceptionally high price to pay for any insurance policy or for any lollipop, unicorns, fairy tales, pixie dust energy policy of the future. Second source is the United States Energy Information Administration. What they do is they take the latest and greatest. We're often told, oh, but solar costs have come down so much. Wind technologies have so improved, they've come down so much. So they're forecasting, looking ahead at technologies at these facilities, wind and solar power and others, put into place in 2016. So the most up-to-date technologies. And they look at various energy options, and they have charted out the costs. By the way, these are skewed dramatically in favor of wind and solar power for a variety of reasons I'd be happy to explain during Q&A or afterwards. And you'll also notice, and Bob Murray can tell you, by the way, fantastic talk this morning. Thank you so much. Bob Murray can tell you how and why it's skewed so heavily against coal. These numbers are doing everything possible to jack up the price of coal comparatively. But even so, let's take them at their word. Even after it's been doctored like this. This is what the EIA reports. Look at wind power, onshore wind power, twice as expensive as the least expensive conventional power option. Offshore wind power, 3 times as expensive. In other words, it's saying the same thing as the Brookings Institute. It's confirmation. Solar thermal, 3 to 4 times as expensive. Solar photovoltaic, you're now talking 5 times more expensive. This is the price we pay if we go down the path that they are proposing. These have real harms. These are impacts that families of all races, of all incomes, especially people who are living in poverty, but these have real implications. That's less money in your budget for nutrition, for health care, for education, for quality housing, for durable consumer goods. Those have real-world impacts on people's lives. Taking a look at some of the states that have moved on their own, because even when President Obama had large majorities in the Senate and in the House, he could not get cap and trade carbon dioxide restrictions passed. He does not have a mandate from the American people. But nevertheless, especially in the middle to the late part of the last decade, there was a movement among states to impose renewable power mandates. Right now, there are 28 states with renewable power mandates. There were 30 a year ago, but 2 of them have repealed their mandates. In both states, led by the same folks who pushed for the mandates in the first place, they saw the energy prices rising out of control, and they said, we made a mistake, let's get rid of it. But for those 28 states, since 2008, which is when most of these were put into place, only a couple hadn't been put into place by then, electricity prices in states with renewable power mandates, in other words, with more wind, with more solar, their electricity prices have risen twice as fast as the national average. Twice as fast. That shows it's common sense. We know that if wind power and solar power is so much more expensive, as the Brookings Institute, as the federal government, the Obama administration's EIA report, you're going to see that in the real world, and we see that in these 28 states. Oftentimes it's been argued, well, the only reason why conventional power, fossil fuels are less expensive is because they're so heavily subsidized. Or if it's not, that's the reason why they're less expensive. Just fairness dictates that we should have subsidies that are going to prop up wind and solar because fossil fuels get them too. Well, let's take a look at the hard data. Again, this is the Energy Information Administration under the Obama administration. 2013 is the latest year for which they published comprehensive data on this. It's very hard to go through and pull out all the subsidies. Here's what they report. Wind power by itself receives more subsidies than every conventional energy source combined. Solar power by itself receives more subsidies than every conventional energy source combined. By themselves. Don't let anybody tell you that they just need to level the playing field. Here's a chart. This is wind power. Solar power is essentially the same. This is solar power. Wind power is essentially the same. You see in blue the solar power subsidies. You see in purple, green, and red the combination of coal, oil, natural gas, and nuclear power. Now here's the real doozy. Keep in mind that wind power powers less than 1% of our electricity. Some people, as a free marketer, I say government should not be picking winners and losers in a marketplace. Some people say, yeah, well, if we have some officials that are enlightened, maybe we should. Okay, so then we should be entrusting them to pick winners, if they're going to do it. Who are they picking? Here we see, this is a chart, subsidies per megawatt hour of electricity generated. They're picking solar power, the biggest loser in the bunch, and look at the small slice of that pie. Next week is Thanksgiving. I'm going over to my mother-in-law's house. I want to get the smallest slice of pie possible because I hope she's not watching. She's not a good cook. I can't get a slice that small. I just can't do it. But that's what the federal government is doing regarding subsidies. It goes all to solar and nothing to coal, nothing to natural gas, nothing to any other source. Don't let them tell you otherwise. What about jobs? Solar jobs, wind jobs. You often hear, well, this wind project, this solar project created umpteen thousand jobs. Well, take that with a grain of salt. First of all, any jobs that are, quote, created as a result of renewable power mandates especially, but also subsidies, they're not created. They're shifted from other parts of the energy economy. If you say by law that wind and solar power must comprise 20% of your electricity mix, you are taking 20% of the market away from coal, away from natural gas. You're not creating jobs. You're stealing them from energy sources that are more productive, more economical, more efficient. You've created nothing. You've just shifted them from one industry to the other. But it goes beyond that. Whenever you hear that argument, and many of you know this analogy, but I want you to think of that broken window. And let me explain why. The federal government can create a program where we pay people to pick up stones and throw them through windows. That's a great jobs program. We're hiring people. We're going to have all sorts of new workers throwing stones. Those are jobs we've created. We're going to create jobs throughout the window repair industry. People are going to have to repair those windows. Look at all the jobs we can quote. But what you don't see is that in order to keep these windows repaired, homeowners now have to take money that they currently spend on nutrition, on education, on health care, on all sorts of things that make our lives happier, healthier, and longer lasting. And now we have to spend them just to keep our windows repaired, which we didn't have to do before. The same concept applies when you hear about green energy jobs. We are being forced to pay higher electricity prices for the same electricity that we were getting before. That means we're taking money out of every other sector in the industry, every other sector of the economy. So yeah, you can point to some jobs shifted, not created, but even if you forget about that, still we're paying for it everywhere else. It is a net jobs drain. Economists in Spain, they studied this same question. They found that 2.2 jobs were destroyed for every single green job created. Economists in the UK found that in the UK, 3.7 jobs were destroyed for every green job created. So whenever you hear this green energy project created 10,000 jobs, then tell yourself in your mind and tell other people, okay, it created 10,000 jobs and it destroyed 22,000 or 37,000. I'm going to skip over that just for time constraints, and I'll skip over that as well. Environmental issues. But by the way, you can ask me about that in Q&A. You can ask me about energy independence and Spanish economy. Environmental issues, the other side of the argument that I get. Well, but this is so good for the environment. I mean, even if global warming isn't a crisis, even if the science presented by Dr. Linz and Dr. Happer and others, even if that's the case, we're still having these environmental benefits. Are we? Is carbon dioxide really the only environmental externality of energy use? Even emissions as a whole. Let's take a look at that. Here, this is from EPA. Again, I'm not cherry picking my sources. This is an EPA chart. This is charting the bottom line, the dark green line. Those are the 6 principal pollutants that EPA tracks. That's what's happened to emissions since 1980. They've declined by 63%. It is not like we have this air pollution crisis that we need to crack down on energy sources to address. What's the cost of chasing down the last final molecule? Our air is getting cleaner all the time. Solar power, other environmental externalities. It requires 40 square miles of solar panels to replace a single conventional power plant. I'm sorry I don't have a source on that. I'm usually very diligent about doing so. If you were to internet search a report I wrote for the James Madison Institute, A Bridge to Florida's Energy Future, I have the sources for that. I can also provide it afterwards. But 40 square miles of land. If you are a land conservationist, this should be troubling to you. Also, solar power is water intensive. Solar thermal requires twice as much water as coal power, 4 times as much water as natural gas power. Where does solar power make the most sense, or the least amount of bad sense? In the desert, where the sun shines a lot, where there's very little water. And now you're taking away more water, unnecessarily high amounts of water. That is an environmental externality. Rare earth production, I'm going to hit that in just a second. Wind turbines, even more so. It requires, according to the American Wind Energy Association's own numbers, 600 square miles of wind turbines to replace a single conventional power plant. If you are a land conservationist, if you like nature, this should trouble you greatly. If we're going to put a price on carbon dioxide emissions, we need to put a price on that as well. We also need to put a price on bird and bat kills. 1.4 million birds and bats are killed each and every year in our country by wind turbines, including many protected and endangered species. That's while producing only 3% of our electricity. If we ramp it up to 20%, 30%, et cetera, those numbers go up still further. By comparison, the BP Gulf oil spill, as much as it would have been so much better for our environment if it had not happened, the U.S. Fish and Wildlife Service, they tallied the total number of marine birds, marine mammals, marine reptiles killed as a result of the spill. The total number was 6,900. That's a once-in-a-generation event that killed 6,900. Compare that to wind turbines that kill 1.4 million each and every year. So when President Obama went on television before the week was out and said, this is why we need more wind power, absolutely not. Just the opposite is true. One final point to keep in mind regarding wind power, what distinguishes it from hydropower? The same folks that are global warming activists, they don't want hydropower. Their objections are, well, it displaces rivers and streams and has an impact on fish. Well, wind turbines displace our natural landscape even more so, and they have even more negative impact on wildlife. Rare earth harms, and I'll close on this. Rare earth harms, rare earths are essential for the production of solar panels and wind turbines. It's not that they're exceptionally rare, it's that they're spread out. It's not like rare earths run in veins like oil, or excuse me, like coal, like iron ore, et cetera. So you have to disrupt a lot of land to produce it. There's also a lot of toxic runoff. According to Yale University Environment Reports, a lengthy quote, I won't read it for you. You can read it yourself or take my summary. It's horrible. It's among the most environmentally destructive practices there are. That's what you're doing to produce wind turbines and solar panels. So again, when people say, well, it's good for the environment anyway, even if you don't believe Dr. Happer, Dr. Linz, and others, no, it's not. No, it's not. Conventional energy is much more beneficial for our environment along any number of lines than the so-called solutions to these fictitious environmental claims. So with that, I will turn the mic over. Thank you so much. It's been a pleasure. Thank you.
I hope you feel more and more edified and probably more and more angry as you're listening to some of these presentations. Well, next we get to hear from someone from across the pond, and it's always fun here in Texas to hear a completely different accent than what we're used to hearing from. So next we have the distinct pleasure of hearing from Rupert Darwall, who is the author of Age of Global Warming, A History. His book holistically examines global warming and how its wide acceptance implies retreat from the scientific standards set during the scientific revolution in deference to authority. So it's quite an amazing shift when you think of the history of logic and reason in the West and how we've actually come full circle with the issue of global warming and science. His work has appeared in the Wall Street Journal, National Review, Daily Telegraph, and The Spectator. He has worked in finance and was a special advisor to the Chancellor of the Exchequer, and I've always been jealous of England for having such a cool title of a public office. I mean, you don't see chancellors of exchequers here in America, and we're jealous of such a title. Darwall is a graduate of Cambridge University, where he studied economics and history. Ladies and gentlemen, Rupert Darwall.
Thank you very much, Chuck. It's really great to be back in Texas. Thank you, Kathleen, for the kind invitation. You can always feel the energy. When I come here, you feel the energy, and it's not the energy under the ground, it's not the hydrocarbons, it's the energy of the people. It's absolutely, you come back energized from Texas. And after James's terrific talk on the environmental consequences of so-called clean power, I just wanted to step back a moment and put that and the science into a political and historical context. What are now the tenets of climate science orthodoxy, the ones that if you don't subscribe to makes you a climate denier, are inextricably bound up with a political ideology, and that ideology is environmentalism. The fundamental claim of environmentalism is that industrialization is upsetting the balance between mankind and nature. By destroying fragile ecosystems, we are imperiling our own survival as a species. So to take an example that we've been talking about today, man-made climate change must therefore be catastrophic. From the 1960s onwards, this belief led to a recurrence of environmental scares. And I use that word advisedly because that's what they were. The first one was sparked by Rachel Carson's Silent Spring, was the pesticide scare, in particular DDT. It led the Nixon administration to announce the EPA's banning of DDT on the eve of the first UN conference on the environment in Stockholm in 1972, excuse me. Nixon's DDT ban was pure politics. What else would you expect? And of course, it's just like President Obama's ban on Keystone XL just before the Paris Climate Conference. And here we come to a common myth, which James has alluded to, about environmentalism. That is, it's about conserving nature and preserving endangered species. In fact, environmentalists' concern about nature is very partial. It depends on the cause, not the effect. One reason environmentalists campaigned against DDT was because it allegedly led to thinner eggshells of eagles and other raptors, putting their survival as a species at risk. We now know that was false. Raptor eggshells had been thinning long before the introduction of DDT. On the other hand, environmentalists don't object when raptors are killed in environmentally friendly ways. Eagles and other birds of prey are attracted to the thermals you get in hill country. Those same hillsides are also used for wind farms. So which should it be, raptors or wind farms? For environmentalists, the mass eco-slaughter of eagles, raptors and migratory birds by the rotating blades of wind turbines is necessary. Wind farms good, coal-fired power stations bad. The IPCC even has a set of wholly spurious numbers to justify the wind-powered avian holocaust. As you can see, the determining factor is the cause, not the effect, the death of eagles. After DDT, next down the pike was the acid rain scare of the 1970s and 1980s. In many respects, acid rain was a dry run for global warming. They had the same enemy, coal-fired power stations, and they had the same answer, emissions cuts, sulfur dioxide for one, carbon dioxide for the other. The National Academy of Sciences linked the two. The science of acid rain, it said, was much further developed than global warming. What the NAS doesn't want you to know is how the supposedly settled science of acid rain subsequently fell apart. Sure, power stations make rain more acidic. Rain is naturally acidic, especially after thunderstorms. But acid rain wasn't causing lakes to acidify, it wasn't destroying forests. A handful of brave scientists found that changes in land use, not acid rain, had caused the lakes of the Adirondacks to become acidic and lose their game fish. The EPA knew all this when it pushed through the Clean Air Act amendments through Congress and delayed publication of the final report of the 10-year federal acid rain research program which set this all out. Yet 25 years on, the EPA's website falsely states that acid rain is a serious environmental problem affecting large parts of the United States that is particularly damaging to lakes, streams and forests. How can I say this politely? What the EPA asserts about acid rain is a downright scientific fraud. Given this, does one Does anyone really think that the EPA is in the business of discovering the truth about global warming and would tell us if it found anything that might put a question mark over what has become the politically settled science? So perhaps it's worth going back to what climate scientists were saying about global warming before politics settled the science. The first chairman of the IPCC, Bert Berlin, acknowledged that man-made global warming was not, quote, something which you could prove. The IPCC's first assessment report, produced in 1990, is distinctly equivocal. It noted that a global warming of larger size had almost certainly occurred at least once since the end of the last glaciation without any appreciable increase in greenhouse gases. Quote, because we do not understand the reasons for these past warming events, it is not yet possible to attribute a specific proportion of the recent smaller warming to an increase in greenhouse gases. It went on to conclude, scientists working in this field cannot at this point in time make the definitive statement, yes, we have now seen an enhanced greenhouse effect. In climate activist parlance, in 1999, the IPCC were climate deniers. So whenever you hear Bill McKibben or Senator Sheldon Whitehouse or the Attorney General of New York or Hillary Clinton claim that ExxonMobil or whoever somehow hid the truth about global warming, point them to what the IPCC was saying in 1990 and then ask, have there been any scientific discoveries since 1990 to justify changing that conclusion? Sure, we had the hockey stick, now entirely discredited. We've had satellite measurements of atmospheric temperatures, which the climate clerisy prefers to downplay. And we've had 18 years or so of climate model predictions bounding ahead of observations, as we heard earlier this afternoon. A good model, as we all know, is a means of systematically bringing together scientific understanding to yield predictions to test against nature. If the predictions are wrong, it follows there's something wrong with scientists' understanding. And here's the key point that I'd like to make. This is not about advancing scientific knowledge on climate. It's about war, and science is one of the weapons used in that war. Science has been weaponized. You don't have to take my word for it. There's a slide I'll just put up, and you can boo and hiss at this. It was actually by some Jeremy Leggett, who was joined Greenpeace after Patrick Moore, and it really says it all. This is a war. And it's a war that will decide whether we let the market provide us with the cheapest, most reliable forms of energy to power economic progress, or whether America will follow Europe down its wind and solar policy calamity. In this, President Obama's timing was truly awful. Right at the moment that the President and the EPA are pushing America down the European path of energy purgatory, the Europeans are waking up to the enormity of their renewable mistake. Last year, the European Commission published a paper on its post-2020 climate and energy targets. It gave Europe a get-out-of-jail card. The new renewable and decarbonisation targets would only apply to Europe as a whole. Think for a moment. Imagine if the EPA had set a federal target but no state targets. The Clean Power Plan would be dead. The real purpose of next month's climate conference in Paris is not about decarbonisation. It's about justifying what the Europeans have done and what President Obama plans to do to power generation. And the Islamist atrocities in that city should be a wake-up call to world leaders that the West faces genuine threats to our way of life and to our civilization, and that global warming is categorically not one of them. Ultimately, the outcome of the carbon war will not be decided in Paris next month. It will not be decided in Beijing by the Communist Party of China. The outcome of this war will be decided on November the 8th, 2016. And it will be decided by you. Thank you.
Well, I'm sure that after those three presentations that there's quite a few questions that have built up in the audience. What I'd like you to do when you ask a question is wait for the microphone to make its way to you. And please let us know who you are, and if you have any sort of an organization that you're from, just mention that. And then ask your question. Restrain yourself from giving a speech, okay? We want to hear from our panelists. So, in the back, yes, sir. Actually, we had two folks in the back. So let's go first with the person sitting down in the white shirt, and then the second question, the individual standing behind him.
Yeah, I'm John Wood, not representing anybody but myself. And is this on? Yeah. Okay, good. The pop science fashion show moves on from decade to decade. The politicians take advantage of that and mint profits for them and their people. How is the best way to get this ridiculously simple argument framed so that more people hear it? Because I'm an engineer. With 3 simple equations, it all doesn't make any sense. But yet, huge chunks of the scientific community bow down to this, even though they can disprove it with a pencil. Does anyone want to answer that?
I can start. Oh, look, I'm on. This is great. Don't even need a handheld mic. First of all, I would encourage anybody in this room, anybody watching via the live stream, tell your friends and neighbors, don't be as discouraged as the media wants you to be. We have, as opposed to 40 years ago, 40 years ago, what would we have to get our message out? We'd have 3 networks, a couple national magazines, your local newspaper. The truth would be buried. Now we have the internet. Now we have cable television. We have national talk radio. People are writing letters to the editor to their newspapers. And what's amazing, and even amazes me, I'm an optimist and it still amazes me, I'll give talks in front of grassroots groups, and I'll have, here, what did I have, 15 minutes? I might have 20 minutes, 30 minutes. And there's only so much I can put in. And at the end, during Q&A, I'll have people routinely, well, Mr. Taylor, that was fine, but you didn't even mention this. You didn't even mention that. People understand. And that's why in poll after poll, if you ask people, when people are asked about global warming, they're much more skeptical than the media want us to believe. Now, how do we get the message out more effectively beyond that? Some of the means that I just mentioned, encourage people to visit some of the websites. whatsupwiththat.com is a good website. Encourage people to go to the Manhattan Institute, the Heartland Institute, Heritage Foundation, CFACT, climatedepot.com, Mark Morano. These are ways that the information can, will, and does get out. It is an uphill battle, and that's a good challenge for people like me to make sure on the Heartland Institute website that we not only are producing the news of the day that debunks the asserted crises, but to have a concise explanation that people can understand in 5-10 minutes. That's a great question.
Does anyone else want to take on that question, or should we move to the next?
Yeah, I just like to, it costs you more, it doesn't work, but the most important thing, as James says, is to debate, to dissent, and for people to know out there are people who share their views. That last, I think, is the most critical thing.
I think I would add one point. I think the challenge is, Europe's demonstrated the challenge, is that politicians, the political class, can run against the sentiments of the people for a fairly long time. So you can have extremely bad legislation passed and policies and programs put in place, despite the skepticism that is clearly evident in the public about doing something. Everybody believes it's real, whatever that means. So I think it's a political challenge. I would just say the toolkit we should use, in my experience doing policy, is a variant of what Dick Lindzen said. Don't take the bait. When we get dragged down the wrong corridor of the debate, that's not saying that when you are by yourself with a policymaker and they really want to argue the science, fine. But in the general public sphere, that's the look squirrel deal. What we really want to focus on is essentially what Bill Gates said, what James has said, what Rupert has said. This is very expensive. That has impact politically. If the expenses are made clear, and there's a good track record, good, I mean facetiously, in Europe now, we might have a shot at taking the air out of the balloon.
When you mentioned the look squirrel, could you just expand on that just a little bit? What is the look squirrel that the other side uses to derail the debate?
To stick with Dick's point, I mean, if we're arguing over whether or not scientists are being disingenuous in a particular domain about a variability that we suspect they might be, let's say they're not bad and evil people, they're just pushing it in the direction of what their belief sets are. So we could argue about the minutiae of the science, whether you made the adjustment plus or minus a few hundredths of a degree, and whether they should have done that or not done that. It's irrelevant. It's not a good thing for to hold hearings on. It's just the hearings we should be holding on are issues James pointed out. There are EIA data, some of the track record, things that Bill Gates is saying. The electric rates are going up for the first time in the United States in 70 years. So we have a long-run trend of declining electric costs for Americans. Now they're going. In the last 10 years, they're going up. This is not a good thing for economies, and should be pointed out. We know why they've gone up, because you just say they've gone up, and when somebody says why, well, these mandates. You want more of that? We'll get it to go up more. Right. These tend to be fairly powerful things in the political environment, but arguing science is extremely difficult in that political environment, as you experience.
Yeah, poppycock.
Exactly.
Right, exactly. In the back, yes.
Hi, I'm Charlie Drebner with the Institute of Energy Research. James, you did those charts you had about, very illuminating about subsidies for the various segments. What's your definition of subsidies? I know a lot of times politicians they'll interchange the word subsidy with a real tax provision that everybody gets. So, I mean, and your data, with the data that AEA and everybody said, did you differentiate that a little bit more for us?
Yeah, and great question, and thank you for asking it. And you bring up a good point, because oftentimes people will try to, for example, say that every expense that we incurred as part of the Iraq War was a subsidy for oil or something stupid like that. So what I like to do is I like to go to the most objective sources as possible. If I want to skew one way or the other, I'll skew to Brookings or whatever else. So the source of that data was the U.S. Energy Information Administration. And as they defined it, I don't have it in front of me, but essentially it was money given to a particular energy sector that is directed toward that sector. So what will often happen is, if there's, for example, a tax provision that applies to every company in the American economy, and because the oil industry, whatever else, is a large industry, if you want to call that a subsidy, then you can always say, oh, well, they're more subsidized than anyone else. But it's not. It applies to everybody. So what they're looking at is when you're directing these provisions at particular energy sources. And that's really, I think, the most honest definition of subsidy. Great question. Thank you.
We have a question down here.
Question is to any or all of you. I'm going to make the assumption that you speak to more hostile audiences than this one occasionally. And I'll make the assumption that you share panels with people that have very much disagreement. You've presented very good arguments, very good thoughts, and very good statistics. What do they come back at you with when you say this? Do they come back with facts, statistics, or is it just a religious argument back to you?
I guess I'll start, seeing as I'm speaking a lot lately anyway. They come back with name calling. That's what they do. They don't have facts and information. Do an internet search. Taylor Bellamy climate debate. This was a Florida State University faculty member I debated probably 2 or 3 years ago up in Tallahassee. And you'll see what happens typically when you have this debate. Rarely will they have the debate, but when they do, it's name calling.
Yeah, I did a talk on the Isle of Wight a couple of weeks ago, and I was quite surprised because there'd been a project to build a vast wind farm between the Isle of Wight and the Jurassic Coast off Dorset, which is an absolutely amazing stretch of coastline. And I kind of assumed that they'd be against this. And I was speaking, and it turned out that very few people around the area who were in favour of these wretched wind farms were actually all in the room with me. But what it came down to was values. They said these things are beautiful. And I can't argue against people who say wind farms and beautiful sites are actually enhance the natural beauty. I mean, that's a value judgment. But what you can point out to people is that they don't work and they cost a lot more.
Other question? Yes. Over here in the back.
Bill Dixon, retired engineer. I have a question on the capacity for the country to establish more wind farms, more solar farms. What level of, let's say, land use, you talked about the number of acres for 600 acres, something like that?
Square miles.
Square miles of usable or economical, at least in their current terms as they define it with their subsidies. What's our capacity of the country to produce wind, to produce solar?
Yeah, that's a very good question. You could always ramp up with scale and produce more of it, but one of the charts that I thought was fascinating, Dr. Beisner, when he discussed dispatchable versus non-dispatchable. And so what happens is the more solar and wind power that you have on the grid that you can't predict, that ramp up and down, the more that the grid is strained. And the more you have to have backup power sources, whether it's coal, natural gas, that have to ramp up rapidly. And the more that you have wind and solar, the more they have to do that. And when they do that, it's much like driving a car in city traffic versus highway traffic. If you are driving at the same pace, you can drive much faster on the highway and still get better miles per gallon than driving in the city much slower. And the same thing happens. You're increasing the inefficiency of the backup dispatchable energy, and you're also increasing their emissions. And on top of that, you're putting strain on the grid because they have to keep it in sync. So I don't know if there's a hard number that says this is what we can build out to, but the more you add, the more difficult it becomes to utilize it.
It's actually easy to calculate the total land use requirement. And that's one of those look squirrel arguments, of course. It's a lot of land, and it would be, in my view, environmentally damaging and not aesthetically pleasant. But the United States is a big place. So if the only calculation is there enough land to put enough turbines and solar cells to produce the energy America consumes? The answer is yeah, easily. It's a big country. It would be extraordinarily expensive, it would be environmentally damaging, but it's not a land constraint problem.
If I can just add a quick follow-up. I remember when I was in 8th grade, I wanted a red Fuji bike so bad. And the reason I wanted it was because everyone else had blue. It was a novelty. If everyone had red, I would want blue. As long as there's not that many turbines, when you see a turbine field, you say, oh, that's pretty cool. I mean, it's kind of aesthetically pleasing. But where do wind turbines, where are they most productive? Essentially mountaintop ridges, coastal shorelines, open plains. These are the places that if you're going to have a value assessment in terms of beauty, in terms of aesthetic pleasing, those are the places where you want to preserve. Once you start ramping up more and more turbines, I think they lose their novelty and they lose, oh, look how beautiful it is. I mean, now you can't look at any mountaintop ridges anymore. I think that people would change their minds quickly.
The other thing about when you have wind and solar at huge scale is that you destroy the economics of dispatchable. And you end up, if you want to keep the lights on, you end up subsidizing the gas and coal plant,
sure.
Because
Exactly.
that just gets wiped out by zero marginal cost wind. And that's a cost that people in Europe are only beginning to realize that they're incurring. That's an additional cost.
Another question right next to the retired troublemaker, engineer.
I'm an unretired troublemaker. Charles Curley, Wyoming Liberty Group. Your figures on how many square miles would be required to replace a conventional plant, does that include how many square miles of transmission line you need to get it from, say, Wyoming to Los Angeles?
That does not, and that is another fantastic point. See, again, the value of understanding. People know a lot more on this topic than we give them credit for. Don't give up hope, don't be discouraged. Great point, yes, that's additional land disruption.
It's actually an underestimate. It's that the transmission corridors are de minimis in terms of total land use. The real problem is they're doing spontaneous assumptions. They dispatch at grid scale and use storage, which is the trope that the Greens like, obviously requires building more capacity and storing it off when the wind turbines are not operating. If you don't want to use coal and gas for when the wind abates and you want to store it, then you need to triple the land use per megawatt of installed capacity to compensate. And then you have to count the land you use either for pumped hydro storage, compressed air storage, all those things. All these things should all be calculated. I mean, these are not difficult calculations, and they don't tax the land in America. What they tax is the people, it's the economy.
And I'll add, there's a lot of eminent domain that goes into the process
Sure.
of transmission as well, which should be concerning to at least some people.
So a question though about the storage that is often completely brushed over. We heard a lot of talk a while back about kind of an adaptive or a smart grid that could connect various wind fields and kind of adapt real time.
Sure.
Does that show any promise of actually coming into existence? And if it doesn't, if it is, for example, hydropower, is that efficient at all to use periods of high wind to pump water back uphill, or do do you lose 4x or something like that in
No.
efficiency?
Pumped hydro is the cheapest way to store electricity off peak in terms of storing it as another form of energy. It's just, it's potential energy pumped up a hill. It has a round-trip efficiency of about 75%, 80%. So it's not too bad, and it's very inexpensive. It's pretty land-intensive, and it's geographically isolated. You have to be where you obviously have. The theory that was put forward in Europe, the Europeans wanted to build a supergrid, right? The way you solve the problem with wind and solar is that there's always wind blowing and sun shining somewhere. So if you build a grid big enough, a supergrid, then where the wind's blowing, you move the power to where the wind's not blowing, and the day-night cycles are solved by simply, having long enough transmission lines to make the difference up. Those are pretty long transmission lines. Not